So today we're going to begin our first lesson on observing motion, and we call a physical representation or a visual representation of motion a motion diagram. So a motion diagram is when we observe a motion occurring and at some time interval we plot the position of the object that is moving. So to give you just a really basic example, let's start with someone walking across a room at a steady speed. So walking across the room. And what's important here is at a steady or constant speed. Okay, so if I was going to draw a motion diagram and I observed someone walking at a steady speed, I would draw an image of that person at every time interval, so like every second. And it would look something like this. Okay, so this would be like 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. And you can see that for every single time interval, the distance that is covered is essentially the same, or as well as I can draw it. Okay, so this change in position is equal to this change in position, this change in position, and this change in position. Okay. Now, if we were going to draw a person, let's say this person was walking across the room and they were speeding up. Okay, so in this case, we have speeding up. This type of motion diagram would look like this. First second there, here. We start slow, and then we start to get faster and faster and faster. Okay, so you can see that at every time interval, the ground that is covered gets larger and larger and larger. So this is when someone is speeding up. Okay, and then again we have our time intervals. Okay. Now, let's look at a motion diagram of somebody who starts fast and then slows down. Okay, so we're going to have one of somebody slowing down. Okay, so if we looked at that, we would start, draw our images. Okay, so we can see over the time period in the first second, covers a lot of ground going fast. The second, less, and then less, and then less. Okay, so these are motion diagrams that of us observing an object in motion. Now, we can observe all different kinds of objects in motion. You know, I drew little stick figures for a person. But what we can do is we can represent any object using a particle. Okay, so the particle model is when the object is a dot or represented by a dot. And it makes it easier for us to draw. If we were observing a car, we wouldn't have to want to draw a car. Okay, so a particle model is when the object is represented by a dot. And we'll do a couple examples of some particle models. So those are real basic examples, okay? And I told you whether or not the object was speeding up or slowing down, but let's look at a couple other scenarios where you have to use your intuition about whether or not something is speeding up and slowing down, okay? So the first one that I want to look at is an inclined plane, or like a ball rolling down a hill, okay? So for this example, I'm going to actually draw a hill. Okay, and as the ball rolls down the hill, we know intuitively because of gravity it starts to speed up. So we would start and have our original position, and then as it goes down the hill, it goes faster and faster, right? And then it would continue along here sort of at a constant speed depending on friction. We'll get into all that later. Okay, but we can see for our inclined plane that is speeding up because we're covering more ground in each time interval. Okay. Now, another example would be an example of dropping something. Okay, so if I was going to drop a ball off of a cliff, okay, so here's my cliff, here I am. Of course, this isn't necessary for the picture, but you would see that as it fell, it got faster and faster, right? So it's accelerating down the hill, okay? So these are just basic examples of motion diagrams, and what we're trying to get across here is the relative change in position over a time interval. And we'll talk next time about what that means, how that's defined, and go a little bit more into detail about calculating motion and calculating these changes in position over time.